Hey guys, welcome to Poor Man Mods. Today we're going to be assembling the rotating assembly in my 2JZ GE, which I'm putting all forged internals in it, and it will be going into my Mark III Supra, and it'll be a 1.5JZ. So this is starting out as a GE block, but all the information that we're going to go over in this video pretty much is going to be the same for the GTE and also the 1J. So in this video, we're just installing the crankshaft and the rods and pistons, but there is a ton of information we go over, a lot of information that most videos don't go over. We're going to show you how to find the correct piston ring gap, we're going to show you how to gap the rings, and then we're going to show you how to plastic gauge the main bearings and also the rod bearings to make sure that your clearances are correct. There's a lot of technical info in this video. Hopefully it will help out a lot of people. We're doing Manley H-beam connecting rods and Wiseco 0.5mm larger pistons. And we're also using ARP hardware. So a lot of the specs that we're doing are not Toyota specs, such as the gapping and also torque. And I'm going to show you how to find all the information if you're doing a similar build. If you're just doing an OEM rebuild, it's even easier. You just follow along with the factory service manual. But in this build, there was a lot of information that I had to find out for myself, and hopefully that makes your building experience quicker and easier. Now for gapping the rings, this is a tool that I designed and 3D printed, which I will have available in my store, which I'll have a link to my website below, fredtechlighting.com. Now what this does, when you put the piston ring in the cylinder, this allows you to put it about 1.5 inches deep into the cylinder, and it'll be perfectly flat. Now you can use a piston, but it's not ideal to keep doing that with your piston. You could drop it, and also this has a nice handy dandy handle on the back. Now you don't need this, but it will make it a lot easier, and I like using this better than a piston. And if you're interested in something like this, I will have it for sale in my website down below. Another thing that is necessary that Wiseco recommended with their pistons is that they tell you to install the rings, the top two rings, with a piston ring expander tool. They don't want you twisting the rings on. That can damage the integrity of them or just totally break them. So you should invest in a pair of piston ring spreader pliers. I'll also have a link for these down below. And you can get away with using a universal piston ring compressor. I've used that in the past. I used that on my 1UZ build that I did a couple years ago, and man, what a hassle they are. And I had so many misfires with them where I'd try to push it in and it wouldn't seat right, and the piston rings would expand before getting into the cylinder. But I went ahead and purchased the Wiseco 86.5mm piston ring compressor. And so this is specifically designed for these 86.5mm pistons, and it worked flawlessly. I didn't have a single miss when installing these pistons. They went right in every single time and just made that process so much easier. Definitely worth the investment, saved a lot of headache. So before doing any of this work, I sent it to a machine shop and basically just wanted them to refresh it, and that's why I went with 0.5 millimeter larger pistons. Not necessarily for the added displacement, but when you go with a little bit bigger of a piston, instead of honing the cylinder, which might not get it perfect, they bore it and make it perfectly straight, true, and brand new for a perfect seal, and the machine shop highly recommended that since it was a higher mileage engine. And so they bored and honed the cylinders, they line honed the main caps, they balanced the rotating assembly and polished the crank. In this video, as long as it is, like I said, it's going to be very full of information. All we're going to be doing is dropping the crank in and getting the pistons and rods in and being able to rotate the crank and move all the pistons. So with that being said, let's get into it. Alright, the engine block came back from the machine shop with the main caps installed, so we're going to remove the main caps, and then we will install the bearings that the machine shop provided. These are the bearings that we're going with. They are the standard thickness, and when you open these, you get two different looking bearings. One side has holes in it, the other does not. The bearing with the two holes or slots, they're going to go on the engine block side. The bearing that doesn't have any slots, that's going to go on the main cap. We did not put any oil or assembly lube on these bearings because when you check bearing clearance, you want to do it dry, so we did not lubricate the bearings. And with that being said, it's important to note when you do that, you don't want to spin the crank with the bearings dry. So we're going to use this plastic gauge to measure our bearing clearance. Cut off a small section of the plastic gauge, place it onto the crankshaft journal, and then we're going to put on our main caps, torque them to spec, pull them back off, and then we'll be able to see how much that little plastic piece spread out, and then that will tell us our bearing clearance. So here I was just a little bit worried about scratching the crank, so I put a tiny bit of oil on the bearings. I just didn't want to scratch anything. Some people say that'll give you an inaccurate reading, some disagree with that, but everything came out to be within spec, so I'm happy with the result. I don't think this really hurt my readings at all. So I'm going to torque these in the proper sequence according to the factory service manual, but since ARP wants to do 3 different steps, I'll do 20 foot-pounds, 30, and then 60. I have these lubricated with oil right now, and there was some of the ARP lube used at the machine shop when they assembled this. So they are lubricated, and we'll do the bearing clearance check. And then for the final assembly, I'll use the rest of my ARP lube on all these fasteners. But they are still lubricated from when the machine shop did it and the little bit of oil that I put on there. So still should be pretty accurate. Let's get these torqued in sequence. As I do this by hand, you can feel it draw down. So I'm just doing these hand tight until I feel the main cap actually seat down. You can feel it drawing, and with these ARP fasteners, it actually feels really nice. You can tell just the difference in quality and feel with these over a regular bolt. These feel super smooth. So got these fully seated by hand, and now we'll start torquing. We'll do 20, 40, 60 foot-pounds. Now you can undo all the work that you just did and loosen these uniformly according to the factory service manual, which the order is the exact opposite of what you just did to torque them. Everything looks to be good. All the clearances are about the same according to the plastic gauge. Let me show you how to read this. So we're reading the width of this piece of plastic or whatever the heck it is that we put on the crank. And this gauge right here tells you your clearance. So the thicker that the piece is, the more that it's spread out, the tighter your clearance. And this guy is pretty much between 0.038 and 0.51, which is within spec for Toyota. So they're all about the same, in between 0.051 and 0.038 millimeter. So our clearances are, in between 0.038 and 0.5, which that's pretty close there. You definitely don't want to get close to the 0.26 or to the 0.06. So we are good to go. Our bearing clearances are good. Now we can scrape off this piece of plastic with our fingernail, wipe the crank clean, and then we can reinstall the caps, and I'll put some more ARP lube on everything. Next, we're going to install the thrust bearing. You want those grooves facing outward. And in this clip here, I actually put engine oil on the bearing. You really should be putting assembly lube on this. I later took the crank back out to put assembly lube on them. I'm not sure why I didn't do assembly lube, but yeah, learn from my mistake and not yours, and put assembly lube on here the first time so you don't have to take the crank out and fix your mistake. The main caps can go back on, and they do go in a very specific order. They are labeled 1 through 7, so you want to make sure you put them in the right order, 1 going at the front of the engine, 7 at the back, and also you want to make sure the little stamped piece is facing towards the front of the engine. This is very, very important. ARP wants you to apply their lubricant not only to the threads of the stud, but also both sides of the washer and also the face and threads of the nut. This is to reduce friction and to make sure that all 60 foot-pounds of torque are being used for clamping and not getting used up by friction of the threads or the washer or whatever. Now we're going to torque this just like we did the first time. 3 sequences, 20, 40, then 60 foot-pounds. Okay, we got the crank installed. Next major part is installing the rods and pistons. And since this isn't Toyota stuff, I've got Manley rods and waistcoat pistons. There's some information we have to find and figure out in order to make this as perfect as we can. So let's start off with piston ring gap. I'm using waistcoat pistons. These are 86.5 millimeter. You'll get this paper with your pistons. This section doesn't apply to us because it's for some like piston ring thing that kind of locks into the wrist pin area, but our piston doesn't have this design, so that does not apply to us. So we need to find out our piston ring gap. For my application, I'm going to be doing medium boost, 15 to 30 psi. And what you do, this chart tells you it's 7 thousandths per inch bore for the top ring and 73 thousandths per inch bore for the second ring. So since we're 86.5 millimeter bore, that comes out to 3.4 inches. So multiply 3.4 times 7 thousandths for the top ring, and that gives us 23.8 thousandths, or we can round up to about 24 thousandths to be safe. And for the second ring, we'll do 86 millimeters, which is 3.4 inches, multiply 3.4 times 7.3 thousandths of an inch, and that gets us 24.8 thousandths of an inch, and we'll probably round up to 25 thousandths. It's very important when doing a high performance application like this. It's most important that your piston ring gap is not too tight. If your ring gap is too tight, especially if you're running nitrous, the rings can pinch together, bend up, and break your piston ring land, and bad things happen. If you have too big of a gap, really the only thing that happens is you lose a little bit of compression, burn a little bit more oil, and lose a tiny bit of power. So it's always safer to run a larger piston ring gap than a tighter one. At least that's my opinion. So this 23.8 thousandths will round up to at least 24, and this 24.8 thousandths will round up to at least 25. That's if we even have to file these things. Now, how do you know which is the top and which is the second piston ring aside from the oil rings that go in here? Here are the piston rings that come for each piston. We have 2 main piston rings here. These are bigger and thicker. These are 2 very thin piston rings. These are your oil scrapers that go with this oil ring. So these go together. And the ring gap for these little oil rings, it says you may be installed without modifying the end gap. The minimum gap is 10 thousandths of an inch. But over here, it says the oil scraper end gap should be between 15 and 50 thousandths. So we'll see where we're at when we install them, but that is the spec for the oil rings. Now, how do you know which one of these is the top ring and which one is the bottom? They're similar, but they are different, and it doesn't tell you on this sheet which is which. In the case of my setup here, on Wiseco's website, it said the top piston ring was 1 millimeter thick, and the second piston ring was 1.2 millimeters thick. So I used my calipers here and measured the thickness. This piston ring here, the shinier one, measured in at 1 millimeter thick. And this guy here, the less shiny one, measured in at like 1.15 millimeters thick. So this is the thicker one, which is the second ring. So this is our top one. Now, these go in a specific orientation. You know, they can't be upside down, so to speak. So they are directional. There is a top and a bottom to the rings. How do you determine that? Well, these are marked. Unfortunately, some rings aren't, but the kit that I have, they are marked. See that N right there? That marking? That means the N is on top. So this is the top of ring number 2, and this is the top of the top ring. And then it does not matter which of these, it does not matter the orientation of these guys, just as long as one of them is on top of here and the other is on the bottom. Now it does matter where on the piston the ring gap is, and we'll get to that when we install them, but if you follow this document here, it tells you where the gaps are supposed to be. They're all supposed to be staggered to make a very nice seal. Another way you can tell which piston ring goes where, this is the bottom ring or the second ring, and it fits in the slot, the second slot here, but it does not fit in the first slot. So it can only go in one spot. Right here, this bottom slot, the very bottom, is for the oil rings. And I did go ahead when I got these, I got the 86.5 millimeter piston ring compressor. So that'll make installing them very easy. But I also 3D printed a tool that should help with this too. So I designed and 3D printed this, pretty basic. A piston will do the same thing, but this allows me to not use the piston and risk damaging it. So what you do, when we go to gap these, we're going to put a piston ring in the cylinder, press this down, and this will seat it nice and square in the cylinder for us to test our gap. All right, but now we need to learn a little bit about this connecting rod here. So I have these Manley rods, and they do come with ARP 2000 bolts, and we need to know the torque spec. When you're dealing with ARP hardware, you don't use Toyota's torque spec, you use ARP's torque spec, and it comes with this little chart here. And to find out our torque spec, so we know it's an ARP 2000 bolt because it says ARP 2000. Okay, so that narrows it down a little bit, between 3/8 and 7/16. So we measured the diameter of this part of the bolt here, not the threads, but this part, and that was 3/8 of an inch. The threads actually weren't 3/8, at least according to my Harbor Freight caliper there. So the shoulder or the neck of the bolt here was 3/8. Okay, so that narrowed it down a bit. And then we got this option here, UHL, 1.5 or 1.6 inches. The UHL is under head length. So that's under the head of the bolt to the end of the bolt. And this is 1.5 inches long. So that means it was torqued at 60 foot-pounds from the factory. And when we go to tighten this bad boy down, we're going to be torquing it 55 to 65 foot-pounds. All right. Now that we know that information, we need to know how the rod installs into the piston because it is directional. There is an exhaust and an intake side. Now, I could not find any documentation here or on Wiseco's website for which side is the intake or which side is the exhaust, but I did watch a Real Street video where they assembled a 2JZ, and I trust Jay over at Real Street, and he said that the larger relief cuts in the piston are for the intake. So the larger reliefs right here, that's the intake side of the piston. And he also recommended when installing the rod to the piston, you want the tabs for the connecting rod to be on the intake side. I guess that's just for balancing. He said he recommends, you know, it might not have to be all on the intake, but you want these reliefs to be on the same side, I guess, for balancing. So if you're gonna put them on the intake, do it all in the intake or all in the exhaust. We're just gonna stick to what he said and have these guys on the intake side of the piston. Now, another way you can pretty much find the orientation of this, it does not specifically tell you intake or exhaust side, but what it does tell you is the offset of the wrist pin of the piston right here. So if you're looking at the front of the engine, you know, it does rotate clockwise like this. So the orientation of the rod in the piston, you can see that the center of the wrist pin is not center with the piston itself. Now I measured on this piston from the outside of the pin here to right here on the piston, that's 11 millimeters. And same thing over here, measured from here to here, and that's 12.5 millimeters. So we have a bigger gap over here. So the wrist pin is 1.5 millimeters closer to this side, and the center of the piston is right here, which is not centered with the wrist pin. All right, so that is mimicking this diagram right here. Now, if you're looking at the front of the engine, like in that diagram, and the engine rotates clockwise, you would know that on a JZ, you would know that the exhaust is on the right side of the car, which would be over here, and the intake is on the left side of the car, which would be over here. So according to Jay at Real Street, the larger relief cuts being the intake, that does match up with that diagram. If you're looking at the very front of the engine, on a JZ, you got the intake manifold on this side and the turbo on this side, which would be the exhaust. So that's how you can determine the orientation of your piston and rod if it's not marked. Now I know factory pistons usually have a dot facing forward. That would make all of this much quicker and easier if they just put an arrow or a dot on this piston, but they didn't. So hopefully all this information helps you out. Another important thing to note is when I had this engine at the machine shop, they did balance this rotating assembly. I'm not sure if they took any weight off or anything or just matched stuff up, but they wrote on the box not to mix up the wrist pins with the pistons. They had the wrist pins matched with the pistons to make it as balanced as possible. So if your machine shop does that, just be careful. Just do one at a time so you don't mix things up. These hog rings, not sure if you can see, but on the piston there is a little notch right here. That's going to help you get this installed. So what you want to do is take the end of the hog ring and you want to make it go just past there. So you want to put the end about here, just past this hole, and then you can stick a pick in here and force it in. Just like that. kind of like 3/4 of the way started in that hole. I don't know if you can see it, but I made up this little wooden punch. Boom. Now we have one assembled rod and piston. First we will lubricate our cylinder wall. And so this is the second or the lower piston ring. And we're going to set this gap to 25 thousandths according to the recommendations from Wiseco. So we have it in the cylinder, but it's not perfectly square. So now it's down in the cylinder and our gap is right here. So we can measure it, and if it's anything like this piston, which I already did, the gap is about 12 thousandths. All right, 19 thousandths. Okay, so the 20 thou feeler gauge does not fit. So our gap is 19 thousandths. So we need to open this up to 25 thousandths. All right, here is a piston ring filer that I bought off Amazon. It was $25 or something like that. This is designed to file down piston rings. And boy, does it take a long time. When I did this on my 1UZ, I used a hand file, and I feel like that went way faster than this. But apparently this is the right tool. Now, when doing this, Wiseco specifically recommends when filing it to go from the outside of the ring to the inside. So if I have the ring in like this and I want to file this edge here, stick it in the tool here, and I want to go in this direction. I guess they're worried about if it possibly makes a burr on the ring. You would want it possibly on the inside and not on the outside. If you had a burr on the outside, it could really mess up your cylinder wall. So Wiseco says to file it from the outside face towards the inside. So that's what we're gonna do. Man, this thing makes a terrible noise, and I will spare your eardrums the pain, but it's very important when doing this, you want to file it as square as possible. And on the previous rings that I did, it took a lot of filing just to make a little progress. So I just do 5, maybe 10 cranks at a time, put this back in the cylinder and keep checking it. Like I said before, it's not totally bad if you make the gap too big, but you definitely don't want it to be too small, and you do want it to be nice and square. If you can see here, I kind of messed up. This one here is not parallel with this one. I did it on a little bit of an angle, so I'll need to fix that. You want it to be as straight and parallel as possible. We did about 10 rotations on that filer, and it got it to perfectly 25 thousandths. And for some reason, this ring went a lot quicker than the rings on this piston. So that's pretty much the process. You need a set of feeler gauges and just do a little bit at a time. File a little bit and check it, a little bit and check it. If you go too big, it's not the end of the world, but you definitely do not want your gap to be too small. So now that this ring number 2 is at 25 thousandths, we can go ahead and gap the rest of the rings. My top ring I'm gonna set to 24 thousandths, and the oil rings, there's a pretty big range there. I'm gonna set my oil rings to about 25 thousandths also. And once I get them all filed, I'll show you putting them onto the piston. Okay, got all the piston rings gapped. Now we're gonna put them on the piston. And we're not gonna worry about the orientation of them yet. We'll get them all installed and then worry about the orientation that Wiseco recommends right here. We will start off with the oil ring here. And you wanna make sure, like in this diagram, that when the ends come together, that the ends are pointing up and not down. So see how the two ends are pointed up where they meet? That's how you want it. You do not want them pointing down like that. This on first. We'll install our lower oil ring that goes below that. Okay, so we got that ring on the bottom side of this oil scraper ring. And then we'll get this one on top of it. And that is how it should look. Now we're going to install the second piston ring, or the lower one here. Now when you install this, it's best practice to use a piston ring spreading tool. And make sure that you install it the correct side up. There's a marking on this ring, and that tells you that it's the top of the piston ring. Finally, the top ring. And now that you got the piston rings installed, you can follow the guide that came from Wiseco for the spacing of the gap, or follow the factory service manual. So I'll be following the instructions that Wiseco presented, and I'll just use my pick here to align everything. If you notice here, I have the bottom of the connecting rod taken off. It's very important that you match the bottom portion to the top portion. You never want to mix up these pieces here. So what I've done is labeled this. So I wrote a 2 on here. This is connecting rod number 2, and the other one that I have in is connecting rod number 1. So I am labeling these so I do not get them mixed up. What we'll do now is put a bearing on here and slide this into the cylinder, and then when we have all 6 installed into the block, then we'll connect these to the crankshaft. These are the bearings that my machine shop provided for me. We will be plastic gauging these to make sure that the clearances are right, but hopefully they're good and we don't need to change anything.
It'll probably be a couple weeks before the next video comes out, but the next step in this process is going to be installing the oil pump. But since this is a 1.5JZ build that I'm doing, the 1JZ is currently in my car, and pretty much once the oil pump is installed, everything else has to come out of that engine. So
Then I gotta pull the 1J out of the car and swap everything over, and that'll take some time before the next video comes out. Hope you guys enjoyed it. Hope you learned something. And stay tuned for the next video in this 1.5JZ build. I'll see you guys next time. Thanks.